Hello everyone. Today in this video we will be learning to check the consistency of a system of equations with three variables. Let these three be the system of linear equations. First of all, we will need to find the determinants d. If the determinant d is not equal to 0, then the system of linear equation is said to have unique solutions. They are consistent. If determinant is equal to 0, then we have two situations. Either at least one of dx, dy, dz is not equal to 0, or all of these is not equal to 0. Then it has no solutions. It is inconsistent. On the other hand, when the original determinant is also 0 and dx, dy, dz all are 0, then again it may have infinitely many solutions or it will have no solutions. Let us see some examples. Example 1. Use Cramer's rule to solve the following equations. Here we have three equations and three different variables x, y and z. First of all, we need to arrange these in a matrix and find the determinant. The first column is the coefficient of x, the second column the coefficient of y, and the third column the coefficient of z along with its sign. Then we find the determinants. To find the determinants, negative 4 times 4 times 2 is 8 minus negative 3 times 1 is negative 3 minus 2 times 3 2 is 6 and 1 1 is negative 1 plus negative 9 times 3 times negative 3 is negative 9 minus 1 times 4 is 4. And when we solve this, we'll get that determinant is equals to 63. Since determinant is not equal to 0, therefore the solution exists. So let's see what are the solutions. First of all, we need to find dx. To find dx, we'll substitute the coefficient of x with the value of the constant 2, 5 and 8. Then find the determinant. So here the determinant we'll get is 441. To find dy, we'll substitute the coefficient of y with the constants. Then find the determinant. Here we'll get the solution, the determinant of dy as negative 189. Now to find dz, we'll substitute the value of z with the constants. Then find the determinant. Here the determinant dz is negative 252. Now we'll find the value of x, y and z using this formula. Dx over d will give the value of x and so on. Substituting these values, then we get the value of x equals to 7, value of y equals to negative 3 and z is negative 4. Therefore, solution is unique. It is consistent. Now let us look at example 2. Solve the following system of equations. And there are three equations. As usual, first find the determinant by arranging the coefficients in the matrix. Here we have 1 times 1 minus 15 minus negative 3 times 2 minus negative 12 plus 2 times negative 10 minus 4. And when we solve it, we get the determinant to be 0. Here the original determinant is 0. So we cannot say that it has a unique solution. It may have infinite solution or it may not have any solutions. So let us check further. we find the determinant dx by substituting the coefficient of x by the constant. By finding the determinant, then as we solve, we get the determinant dx to be -7 for this. Since the original determinant is equal to 0 and at least one of dx, dy and dz is not 0. Here in this case, we have tested dx and we found it is not equal to 0. Therefore, the system is inconsistent. That is, it has no solution. Let us see example 3. Solve the following system of equations. Here we have again 3 equations with 3 variables. To find the determinants, again we take the coefficient of x, y, z. Here we have 1 times 9 minus -9 minus -1 times 3 minus -15 plus 3 times 3 minus 15. So when you solve it further, we see that the determinant of this matrix is 0. So when you calculate the determinant dx, we get the determinant dx as 0. We have seen the original determinant is 0 and determinant dx also as 0. Now let us check determinant dy. To calculate determinant dy, we replace the coefficient of y with the constant in the original matrix. Again, finding the determinant, we get 0. After that, we find the determinant dz. To find the determinant dz, we replace the coefficient of z with the constant in the original matrix. Then when you calculate the determinant dz, we see that the determinant dz in this case is 0. Now we see the original determinant is 0 and the determinant dx, dy and dz all are 0. Therefore, the system has infinitely many solutions, or it might not have any solutions. To see this, let us check the consistency. Putting z is equal to k in the first 2 equations, we get x minus y plus 3k is equal to 6. In place of z, we are replacing it with k. We take the plus 3k in the right hand side and we get it x minus y is equals to 6 minus 3k. This is in the first equation. Now taking the second equation, we replace again z with k. So we have x plus 3y minus 3k is equals to -4. Now taking minus 3k in the right hand side, we have x plus 3y is equals to -4 plus 3k. So now we have 2 new equations. X minus y is equals to 6 minus 3k and x plus 3y is equals to -4 plus 3k. So this represents a system of 2 equations in 2 variables x and y, considering 6 minus 3k as a constant and -4 plus 3k as another constant. We find the determinant of these 2 equations by taking the coefficient of x and y along with its sign. So here we have 1, -1, 1, 3. Calculating the determinant of this, we get 4. Further, we find dx and dy. We already have the 2 new equations, and from here to find dx, in place of the coefficient of x, we are replacing 6 minus 3k and -4 plus 3k, which is considered to be constant here. Then when we are calculating the determinant, we multiply 3 times 6 minus 3k, or the other way, 6 minus 3k times 3 minus -1 times -4 plus 3k. When we are simplifying it, we get the determinant as 14 minus 6k. Then determinant dy, can be calculated by replacing the coefficient of y with this constant. Again, when you are calculating this and simplify it, we get the determinant dy as 6k minus 10. To find the value of x and y, we use this formula, dx over d and dy over d. Dx is 14 minus 6k divided by d is 4. So here when you are dividing the numerator and denominator by 2, we get 7 minus 3k divided by 2. And similarly, 6k minus 10 divided by 4 can be simplified to 3k minus 5 divided by 2. Putting the value of x, y and z that we just have it in the last equations. So the last equation is 5x plus 3y plus 3z is equals to 10. We get 5 times the value of x plus 3 times the value of y plus 3 times the value of z, which is k, is equals to 10. Now we open the bracket and take the common denominator. When you open the bracket, 5 times 7 is 35 minus 5 times 3k is 15k plus 3 times 3k is 9k minus 3 times 5 is 15 plus, now we have 3k here without denominator. So to have the common denominator 2, we multiply the numerator and denominator by 2. So 2 times 3 is 6 and the denominator 2. So we have the common denominator is equals to 10. Now taking this denominator 2 to the other side, we have 35 minus 15k plus 9k minus 15 plus 6k is equals to 10 times 2. So when you are calculating this, negative 15k plus 9k plus 6k, we get 0k, and 35 minus 15 we have 20, and similarly 10 times 2 is 20. So we have the equation 20 is equals to 20, which is true. Therefore the solution is x is equals to 7 minus 3k over 2, y is equals to 3k minus 5 over 2, and z is equals to k, where k is any real number. If k is 1, the value of x and y will depend on 1. If k is equals to 2, the value of x and y will also change. So we have infinite number of real numbers that we can put in the place of k. With it, the value of x and y will depend on the value of k or the value of z. Therefore they are called dependent. The given system has infinitely many solutions. It is consistent. However, if this, which is in this case true, but if this is not true, for example, if one side comes 18 or any other value and the other side comes 20, which is not equal, then if this becomes false, then the system will have no solution. Hence, it is inconsistent. So today, in this video, you have learned how to check the consistency of system of equations with 3 variables. Thank you. We'll catch up in the next video lessons.